So we just talked about using block design to reduce the variability in your experimental units. And directly related to block design, in fact, sort of a subset of block design, is an experimental method called matched pairs. And in matched pairs, you're always only going to compare two different treatments. That doesn't have to be true in just general block design. You could compare as many treatments as you wanted. But with matched pairs, because we're dealing with a pair, of course, we can only compare two things. There are actually two methods for using matched pairs. One method is to take or to pair up your experimental units or your subjects and to pair them in such a way that they are very similar to each other. So perhaps if you've taken just a bunch of general data on the people participating in your experiment, you should know maybe their age, maybe their income level, their gender, basic health history, that sort of thing. And then you're going to pair up people to be as similar as possible. Of course, that won't be perfect, but the idea is that if you pair up people in groups, in pairs that are very similar to one another, then perhaps any difference that you notice in the experimental results is truly caused by the difference in your treatments, not so much in the difference between the two individuals. So again, method one, you pair two similar subjects, and then once you've paired everybody off, you're going to randomly assign which subject in that pair gets which treatment. And again, there's only two treatments, so once you've assigned one member of your pair to get a particular treatment, then the other person in that pair is stuck with the other treatment. So that's method one. Method two for this matched pairs design is a little bit different. And in this method, every single person is going to get both treatments. So each individual subject in your experiment is actually their own control. So here again, we're not pairing off people. The pairing comes from the fact that each person gets both treatments. And this time the randomization comes from the fact that you're going to randomly assign each individual to receive one or the other treatment first. So which treatment they get first, that's going to be the random component. Which method you use is going to be dictated by the type of experiment that you're conducting. Some experiments just won't allow one or the other of these methods. For instance, if you're trying to establish how effective a certain drug is, you probably would not want to use the second method of matched pairs, where you would give perhaps the same person either a placebo or the actual drug, and you would try to see which one was more effective. Using that form of matched pairs wouldn't be a very good idea, because then it would be difficult, especially if they received the drug first and the placebo second. You wouldn't know necessarily if maybe the drug was just still having some sort of positive effect on them, or even a negative effect. However, if you were trying to test the effectiveness of a drug, using the first method for matched pairs would be reasonable. You would take two people with very similar backgrounds, very similar health histories, and then give one of them, randomly assign one of them to receive the drug, one of them to receive the placebo, and then you would take a look at all of your pairs. Obviously, you would have many, many pairs to collect data from, and then you would try to see if the person in each pair who received the drug did better than the person who received the placebo.